Since no student have joined this time, so I'm waiting for 5 more minutes. Uh, Basically, my class timings is 6 to 8. I really apologize that sometimes there is a slight change in time. So please do check in the mails that that you get from NPTEL SOIM team. Please don't ignore that. Otherwise, you will miss the live classes. And live classes are just uh, made in order to have the live interaction, not just to have for the sake of only classes. So I really want students in my class. So I'm waiting for 5 more minutes. Sorry for the slight change in my timing due to some issues. Okay, thank you. My God, thank you so much. Yeah, it is hot. Yeah, yeah. The class is going on. Still, students have not joined because they are not aware of the schedule. Just waiting for 5 minutes. ऊपर से तुम निकलोगे यहाँ से? मैं निकलूंगी मेरे 4 बजे। 4 बजे नहीं निकलूंगी, 5:30 बजे निकलूंगी। 5:30 बजे में तुम्हारा कब खत्म होगा ये? क्या चीज? 2 घंटा है क्या? हाँ, 2 घंटा है। फिर भी देखो, अभी स्टूडेंट्स ने ज्वाइन नहीं किया, मैं वेट ही कर रही हूँ। If they don't join, I'll finish it early. But still वो दूसरी को ज्वाइन किया है, स्टार्ट करेंगे। इसको मैं ढूंढूंगा अपना सेल।
तुम जो बताई थी ना उसमें हम नया क्या कर रहे हैं
इसमें
फ्लेक्सिबल न्यूरल लॉजिक
मुझे तो याद भी नहीं हम क्या किए थे उसमें, कुछ तो किए थे। ठीक है दीदी, आई स्टार्ट।
ओके
थैंक यू यार इसके लिए, बहुत गर्म है। वाओ, that's really nice.
राइस इज दैट जीरा राइस
Yeah, that type of rice only I wanted. I suddenly I remember that it is, क्या बोलते हैं, वो वाला राइस है, तो मैं सोची ठीक है दीदी, आई स्टार्ट विद दिस। मैं रहूंगी 4 बजे से, आप 4 बजे से पूछ सकते थे। Hello all. There's still no students joined, so I have to start. Okay. So in the last class, till now, so far so good. We have seen several concepts of linear independence, and then we saw pseudo inverse, left inverse, right inverse. So in this week 6, Sir taught basically about sensitivity analysis in the first 2 lectures, and then least squares in last 3 lectures. Okay, so basically last 3 lectures was bit similar to week 4. Yeah, week 4, I guess. So in that, as we saw, okay. So in that, as we saw, for tall matrix we can have left inverse, and for a wide matrix we can have right inverse. So in that we saw that in left inverse we can have either no solution or solution, right? So there was a possibility that no solution can exist. So in the last 3 sections of the week 6, sir taught about how can that solution can be found. So basically that 3 lectures are very very good, but in that sensitivity analysis was the extension of the week 5. So yeah, so in the last class we had a very good discussions, and unfortunately I couldn't see many students here because maybe due to the class change they might not be aware. So yeah, uh, the question number 10 that we were solving, if A is just a matrix, you just see this question and give some time to you and then try to analyze what should be the answer for this question. Sneha, you are very new to my class. Like, can I know your introduction? Are you a BTech student?
hello ma'am
Yeah. Yeah, Sneha. So, how many lectures you
hello
have seen?
hello
Yeah,
I'm
yeah.
audible ma'am
Yeah, you're audible. Tell me.
yes ma'am I'm MSc student ma'am
Okay. You didn't join my class before, right?
no ma'am
Why, Sneha?
this
Like,
is my
suddenly,
first
this is my regular classes are from 6 to 8. Like, you are crediting this course means, have you submitted your fees?
yes ma'am submitted
Okay, so why you didn't join earlier?
due to some work ma'am I didn't joined
You are MSc student. You will give exams also, right?
yeah yes ma'am
That's great. Okay, so how many lectures you have seen?
this week I'm unable to watch ma'am due to some activities in our college.
Okay. That's good. So MSc in what, which branch?
Mathematics ma'am.
Oh, that's great. That's why you are learning this mathematics course.
Yes ma'am.
So okay. So basically, I will tell you what we have seen since you are the only student that you joined. Otherwise, in my
Yeah.
class, like almost 13, 14 students used to join, and the class timing
Yeah.
was every Saturday 6 to 8.
Yeah.
But due to some
Yeah.
reason, I have to prepone my class. So that's why
Yeah.
really like I used to have so many interactions and then some solutions, and that's a very great thing. So you join also. Like basically, my
Yeah.
class follows. First, what
Yeah.
we have seen, what is there, what is the content of week 6? Suppose week 6 is there, then we will solve some related problems. So I, in the last classes, I told various tricks also how to learn about tall matrix and wide matrix and where the solutions exist or not. And basically, in the last class, we saw sensitivity analysis. That was the main thing. Uh,
Yeah.
and in week 6 also, like, sensitivity analysis was the extension of that. So due to, like, 6 to 8 was my class, and due to some reasons, we couldn't finish this NPTEL assignment 5. So I
Yeah.
thought, for those like who will watch the recordings, I'm just trying to start from there only. So basically we saw these questions. How can we solve this particular question? So if condition number is defined, then condition number of A can be defined as mod 2 norm of A multiplication with the inverse of 2 norm of A. So in that way, and this is also equal to, this is very important, and this is also equal to max magnification of A, min magnification of A, magnification of A. So that we saw. And and this p norm of any matrix can be defined as max of x not equal to 0, norm of ax divided by norm of x. So it can be any value. So any person had doubt of any values it can have or not. So this is a very simple problem. The 10th problem was left. So that's why they see, we can see max magnitude of a divided by max magnitude of a inverse. Okay, so we saw these questions because this max
Yeah.
magnitude of A inverse is actually equals to 1 upon min magnitude of A. So that's why we can write this as like this. This is
Yeah.
max
Okay,
magnitude of
ma'am.
A divided by min magnitude of A. And we saw that any circle can be transformed into ellipse, so that the major axis and the minor axis, it can be written in the form of condition number. So that's why condition number should be equals to or greater than 1. And uh,
Okay.
okay, so last question was, if A is an invertible matrix, then there exists a unique representation of the matrix L and U in LU decomposition, where diagonal elements of L is 1. So yeah, in the last class we saw that LU decomposition is unique. Why it is unique? Because A was a invertible matrix, and then we are trying to make it as a LU. So why LU? Because this is a lower triangular matrix and this is upper triangular matrix. So L, and then L we are writing as a L 3 2 inverse, L 1 2 2 1 inverse. Like that we are trying to write. And why this is the unique? Because inverse of lower triangular matrix is also lower triangular. So yeah, would like to finish this. Next we will start with NPTEL assignment 6th week content. Then we will see some problems related to it. So give me a 2 minutes. Just
Yeah, okay, ma'am.
So, okay. So Sneha is only there in the meeting. Okay, fine. So in the last class, in this week 6, we saw if y belongs to r power n, then and if we perturbed any variable, then what should be the perturbation of z variable? So that perturbation is given by the condition number, as we can see here. Then this is what perturbation, and these have some properties, like it should be greater than or equal to 1, and 1 only if the matrix is orthogonal matrix. So orthogonal, why orthogonal matrix has 1? Because we saw that this P inverse is equals to P of transpose, because orthogonal matrix have this property of A transpose A is equals to A transpose is equals to I. So that's why this is equals to 1. So, in long run, basically this perturbation, if we don't control it in a proper way, then we saw that that elongated ellipse will be forming, and that elongated ellipse will have the complete dimension change and complete variation of what we want. Okay, so that's why we are making sure this condition number to be within a particular range. So in this week 6, we will see how can this perturbation or the condition number have a lower bound or an upper bound in solving the system of linear equations. Okay, so this is important. For example, this is very important because anyway we are trying to converge into solutions of system of linear equations. Okay, so if ax is equals to b and b belongs to r power n, so if we have to compute x which is belonging to r power n. Okay, so A is invertible. If A is invertible, then A is equals to X is equals to A inverse of B. So what will happens to X? Now we saw if Y is perturbed to Y plus del Y, then Z is also perturbed to Z but del Z. Okay, then we saw 2 norm of del Z divided by 2 norm of Z is equals to this one. Okay, basically I'm writing this one. So what will happen to Ax is equals to B. Now assume B is perturbed to B plus delta B. Now tell what is happening to delta x plus delta x. So I'm asking delta x, the norm of delta x, it should have how much of lower bound or upper bound should be there? Just think. Yeah, so basically it is almost same. Why? Because this condition number of A is equals to condition number of A inverse. So what is happening here? We are perturbing here. So this will lead to pen is not working. Can you give me things? Hello, hello, Murli. Do you have any problem? Hello, are you asking anything? So, okay, till now we saw about this min, max, and magnitude, and then obviously this condition number. So, Murli, how many lectures you have seen? Do you have any problem the last week? Okay, since you joined in the middle, I am not sure. Have you joined in the previous classes? My previous classes? Can you please tell something? It's okay. So yeah, we will continue. So some mic issue was there, so it got resolved. So basically, we saw condition numbers to be between 0 and 1, and also saw previous these things. Like I was explaining. I don't know whether my mic was on or not. So sorry for the inconvenience. But yes, but in this, if eta is there, then eta should if it is approximately 0, then definitely our condition number is very high. Then it is a problem for us. Okay, it should not be there. Okay, so and moreover, now let's go to least square solution. Yeah. Because I have to solve some questions also for you. So that, so yes, least square. So what happens when you have ax is equals to b, and a you can write it like this: a1, a2 to an. And we know this, if we do the linear combination of columns of a, then it will be x1 a1 plus x2 a2, so on xn an. Okay, and you know from the linear independence. Okay, what is that? Linear independence means this particular term, equation 1, that is a linear combination of columns of a, x1 a1, x1 x2 xn are any real numbers or any scalars. Okay, that belongs to R. As of now, we are talking only about the R set, right? Because we saw in the first class what are the fields, and R is nothing but a field. Okay, because their combination only we are talking about. And basically the field, then after that we saw the vector space. So vector space is defined over a field, and the field that we are considering throughout the course is R. And that field is what are the properties of vector space? I was repeatedly telling in the first class what are the properties of vector space: close under, vector addition, and scalar multiplication. I hope you all remember. Okay. It's very inconvenience that for the first time in my class nobody joined, maybe due to the class timing change. But yes, okay. So we will go ahead. Yeah. So this x1 a1 plus x2 a2 till xn an is equals to 0 if and only if x1 equals to x2 is equals to so on xn equals to 0. This means this was the condition for linear independent of columns of A. Okay, now we saw before it only that if we do this linear independence, then the matrix should be, now tell me, Murli, what should be the matrix? It can have three, uh, tall, wide, square. Tell me, what should be the answer? Murali, what should be the answer? So, okay, he's not responding. Yeah, yeah, tell.
Wide, it's a wide.
No.
It's a
If all the columns of A are linearly independent, then definitely it should be square, right?
square. Ah, yes, yes.
Yes. Okay. So if the square matrix is not there, means the linear column independence is not there, then we have come with the two other types of matrix, which is tall and wide. Okay. So in the wide, we saw that there's always a solution exists. Okay. But in tall, there can be or not. So when these two matrix comes into the picture, when these things is not satisfied, okay. I hope up to this point it is clear. And now tall matrix, okay. You have this x vector, you have this b vector, okay. This is A. Now tall matrix means number of rows greater than number of columns. We know this. So far so good. Now what does this mean? For example, you have 1, 2, 3, 4, you have, sorry, 5, 6. You have, how many variables will be there? X1, X2, X3. Because 3 cross 2, so it should be X2. 2 cross 1. Then it should be 1, 2, suppose. So if you try to write this in the form of Ax is equals to B, then how you can write x1 plus 2x2 is equals to 1. Then 3x1 plus 4x2 plus 3 is equals to 2. Then third equation will be 5x1 plus 6x2 is equals to 3. Now, what are the assumptions that you have to take? Now you can see we have two unknowns, okay, and three equations. Okay, so what is happening here? You can't make assumption here. For example, you have, suppose this is opposite, the three equations and, sorry, three unknowns and two equations. Then you can make one variable as an assumption of any values that can satisfy the two equations. But here, that will be case of wide matrix. But here, you don't have this condition. So that's why we had to make least square. So there the big theory of least square comes into the picture. And how least squares, why least squares, we will see. Now only we will see. So the condition number things was, I think that is clear. Uh, and I'm so sorry in the first half my voice was not audible. Uh, but yeah, those who will watch recording, please don't watch this recording if you don't find useful. But yes, least up to from this point you can watch. So we saw in condition number only this is one is the upper lower bound. and then we are going to. So basically, one more interpretation of condition number is very, very important. Then we will go back to this. Sorry for the little switch, but it is very, very important. So what will happen whenever the matrix is ill conditioned? Ill condition means the condition number is very, very high, or it's not good. For example, if it is greater than very, very greater than one, then you're finding it. The linearly dependent columns and rows are there. So that type of question can arise, like how it is there. So basically, if you see from the interpretation of any matrix as a sum of Ci Ai, where I equals to 1 to n, then if it is, you can write this form. So basically, this min magnitude of A is what? You're transforming this to Ax of vector such that norm of x is equals to 1. Why norm of x is equals to 1? Because this one is actually x1 square plus x2 square is equals to 1. So if you write this x1 square plus x2 square, x1 x1 minus x naught divided by a square plus x2 minus y y2 naught divided by b square. So this is forming ellipse where a is equals to b is equals to some value like 1. But here it was the actual transformation. But hey, A, remember this one. This is making that transformation of circle to ellipse. So far we understood this things, okay? But here, if the matrix is L condition, then A is found to be, you know what, is found to be linearly dependent columns and rows. So that is not good for us. That it will create problem in calculating inverse. It will create problem in calculating anything. Okay, so that is a problem. So when we try to find this Ax is equals to b, then what we have observed, this this L condition matrix is making, suppose these are the two black color lines that is intersecting at certain point. But after L condition, after transformation, it is making it to this to green, yellow to green. So what is that it is creating? It is creating the gradual shift from intersection to a parallel things. Okay. Initially it was intersecting, but later it is not intersecting. It is becoming a parallel. So obviously you want a solution, not to be many solutions that to a parallel lines. Okay. Although this is better than tall matrix where we didn't have any solution. But yeah, intersection is far, far, far better than this particular scenario. So this ill conditioned matrix is making this thing from yellow to green. So you can see how it can affect. Pictorically, you should also understand that thing. And this, as we know, you please remember this formula. It will be useful for everywhere. Now Ax is equals to B, where if you do this LU decomposition, then why, we were transforming A to LU, then a LU to QR. Why? Because this is making our computation little easy. I agree that there are so many steps in doing that, but computation is easy in the sense that it is creating, it is helping in finding inverse of a matrix. Okay, so inverse of a matrix is very, very important as far as. So that's why inverse of a matrix is very difficult to compute, especially if you go into higher order n cross n, where n tends to 100 or 200. So that will be a problem for us. So that's why we are doing LU and QR. But in that LU QR also, you are making sure that everyone should be orthogonal. Now you see, if you convert into QR, that is Q is a orthogonal matrix, then this condition number of Q is always 1. So that will not create a problem in sensitivity analysis of later multiplication of any matrix. So that's why one of the reasons that we are doing this QR. Okay, so far we saw this sensitivity analysis, this matrix vector multiplication that gives this same thing, mod of A is equals to mod of like 2 norm of A, 2 norm, and K2 of A is equals to K2 of A inverse. So that's why while solving the system of linear equation, you didn't have any modification in condition number. Okay. So yes. Now, Murli, how many lectures you have seen? So if you have seen week 6, like I just wanted to know how many weeks you have seen.
Ma'am, can't understand your
How many lectures you have seen? I'm just asking.
yes, two lessons, ma'am. Two lectures.
You have seen only 2 lectures.
Two lectures. Before that, I can solve directly.
Okay, okay. Like 2 weeks you have seen.
Yeah, yes.
Okay,
Previous one, sir, is there, and on the previous your lesson, your lecture, I'm saying.
okay, okay. That's great. Yeah, yeah. So that other than this week live session, I think up to five live sessions, my 5 lessons live sessions are good. Like you can see, this live session is actually not recorded properly in the first half, so it's okay.
Okay.
Yeah. But 5 live sessions, like if you watch and you will be able to solve some problems related to 5 weeks also. So okay.
Okay.
So basically week 6 is that uh lower and upper bound for
Lower bound condition.
yeah,
Lower.
upper bound for this condition number is there. So
Yes.
you can just go into it and just try to find. And
Yes.
before going directly into the lecture, if you try to, if you know these things, right? We saw this,
Yes.
this is great. Then how can you find your by yourself? Because everyone's
Okay.
way of proving it is different. So it's better if you can have by your interpretation. Like
Yes.
let's go with
Yes.
the search way. So if you
Yeah, I'll solve the 7 questions.
okay, 7 questions of week 6.
Week 6.
Okay, okay, nice. And you watch all the lectures.
Yes, ma'am. Yeah.
Okay,
Uh,
okay.
mm, yes.
Okay, okay, nice. Can you tell me your background? Like, what is your background?
My, myself is Murali Mohan. I'm working in a Poti Sri Ramlu College of Engineering, Vijayawada, Andhra Pradesh,
Okay,
and I have 17 years of experience in
that's
mathematics.
oh, okay, okay. And what are the subjects that you teach there?
In undergraduate level, BTech, Bachelor of Technology
Uh,
Engineering level.
and
M-
doing this type of course is compulsory for you?
yeah, recently they said that compulsory doing in one semester one course.
Okay, okay, okay,
I completed 2 courses in previous,
okay, okay,
and this is the third course.
okay, okay. Two courses. What are the courses that you completed?
Operation research, basic operation research, introduction to operation research.
Okay, under this sir only.
After then, R programming, foundations of R programming.
Nice, nice. At this age also you are learning this much. That's great.
Yeah, yeah.
Nice. Okay, so as you have seen, so lower and upper bound for condition number is there. Then
Uh,
we will go to least square. So basically, that is a simple proof. Uh, Not to worry much about this. You can just try to learn these things like mod of A. The previously we saw uh, if we perturb y is equals to px. If we perturb this one, then we are getting this condition number of A. Now, if sorry, P. If we perturb this one, then also we are getting condition number of A. That is same. Okay. But what if you perturb this matrix A itself? That is causing a system of linear equation. So that is where the trick comes. Now, the whole lecture second of week 6 is all about that. But yeah, whenever you are perturbing any matrix, so you have to make sure that whether the perturbation is leading and any significant change so that it can not becoming an invertible matrix. So for that, we have to make sure that this is the lower one. Like it should be less than. 1 upon K2 of A, that perturbation of uh, matrix A should be less than this one. Then only the matrix will be invertible. The perturbed matrix that will formed after perturbation. It will be invertible, otherwise it will not be invertible. So that's the case. Okay. So this is invertible. Now this is the proof. I'll not go to the proof because Sir told about Sir proved using the contrapositive. One can prove directly by taking one example of non-invertible. Okay, I used to do like that. Then proving that it is actually invertible. This type of proof we call is as a uh, some theorem we call this. So you can just prove it, no issue. So yeah. So this, if you see this relative error bound, basically this bound is important. How can you find the bound? So this is if you Ax is equals to B, and we know this is the perturbation. So then we are finding the effect of perturbation on x bar. So actually x bar is x plus delta x. Okay. So delta x will be x bar minus x. So here it is written. This is what. So as we know, this is a invertible matrix, so that this should be invertible. So this should follow. Okay. So what should be the bound on this one? So the bound on this one, we have to find it. So a plus delta a multiplied with x bar is equals to b, as we know. Then x bar is equals to delta a x bar is equals to b. If you do these things, because ax is equals to b, then finally after just rearranging, you are finding this one. The delta x of x bar less than K2 of A. So what is happening here? You can find it. You can see directly that this K2 of A is multiplied by with this delta A by A. That is same. Okay, that is same that we saw earlier also. Ax is equals to B, and then y is equals to Ax. Okay, so if this is perturbing, then we are doing this K2 of A. But this is multiplied by delta of A. That is this numerator is same. But you can see this denominator thing. That is 1 minus K2 of A delta A by A. So why this is coming? Because you are perturbing a matrix. Okay, that matrix has a certain property of for that is governing the whole system of equation. Okay, so that's why here it is coming. Now we know if it is well conditioned, why it is equal almost equals to 1, because we know mod of A, if A is less than equals to 1 upon K2 of A for a well conditioned. So yeah, let's define this well conditioned and ill conditioned. So basically well conditioned means it should be square invertible matrix, and the linear it should the columns of A should be linearly independent. Independent only we want, okay. But what if the ill conditioned? Ill conditioned means the columns of A will be linearly dependent, and it is not square. Then it will be ill conditioned. And also we saw the how condition number today in today's class only we saw how condition number is affecting uh, the linearly dependence properties of matrix. If the condition number is very bad, then we saw all the columns and rows of the matrix will be linearly dependent. So in the similar sense, it will be approximately equals to 1. So yeah, this is the final expression. Okay, but this also you please remember, this is important. Okay. So we saw this case 1, case 2. Now let's saw this case. What if you are perturbing everything? Now if you perturb this thing, you find this thing. You perturb this thing, you are finding this thing. What if you're perturbing this A plus delta A2 A plus delta A and B2 also B plus delta B? So what will happen to system of linear equation solution? That is a x bar. That is x bar is equals to x plus delta x, because that will also be added by this particular value. So after doing certain analysis, and also we have to make sure that it should be not it, after perturbation also the matrix So very important for any matrix. After perturbation also the matrix should be invertible. Okay. So what we have found, this is scaled by, like, this is plus. Okay. This is plus delta B by delta B, the mod of B, and 1 minus K2 of A, and it is almost equals to 1 for well conditioned thing. But okay, it's fine. But you please remember this too. So yeah, this is done till sensitivity analysis. Okay. So if you see this posterior error analysis, then we are trying to find this error. So that error will be like, if you see, if A is any n cross n be invertible matrix and x bar will be any approximation to a solution, then okay, that is different. That is for least square. Here the origin of least square will come. But yeah, up to sensitivity analysis, if you have any doubt, please let me know. Otherwise, I will move to least squares. So Ambili also joined very late. So I hope this is clear. I will move ahead. So moving back to least square. So yeah, this is the least square thing. Why least square comes into the picture? This is the reason behind it. So I'll not repeat it. But yeah, you can see a least square. Why the least square name comes? Because the solution doesn't exist in tall matrix. So whenever the least square term is there, then that will be definitely for tall matrix. You assume it. Okay. Okay. So the motivation was explained earlier only. But yes, let's move to. Okay. So basically, if you don't have any solution, then you'll find the residual. Residual means the the residue that left after any approximation, suppose. So okay, now if it takes no solution, then what you will do? You'll definitely try to find an approximate solution. Okay, in that case, okay. So when there is no solution, when we will have that is also very important. When you will have no solution, and when you find approximate solution. So okay, so this is clear that this is defined for tall matrix. Fine. But tall matrix also can have solution or cannot have. Two options are there. Can have or cannot have. Now tell me when this can have will come and when cannot have will come. Murali, you have seen the lectures. Can you please tell me? In what case we are finding the approximate solution? That is fine that this is for tall matrix. But in what case? Okay, so it's okay. If AX is equals to B is there, okay. When B lies in column space of A, then we will have solution existing, and that is also unique. In this case, we are not finding approximate solution. No approximate solution. What does this mean? Linear combination of this column space of A is nothing but column of A is nothing but linear combination of columns of A. Okay. Why there is a unique solution existing? Because B is lying in this column space of A. So there exists unique X that satisfy such that Ax is equals to B. So unique X will be coming here when B lies in the column space of A. Because that column space of A, what does this mean also? Yeah, B lies in column space of A, what does this mean? This means that the combination of x1, x2, x3 means here if you write A is equals to A1, A2 to AN, combinations of A, that makes B. What does this mean? This means A1 x1 plus A2 x2 plus AN xn is equals to B. Okay, this B is vector. So x1, x2, xn will have unique values. Okay, and here only this left inverse will come. Okay, so left inverse, can anyone tell me what is the formula for left inverse? What is the formula for left inverse? So A transpose A ka whole inverse into A transpose. So what will be the solution? Since Ax is equals to B is there, so x is equals to A inverse of, I have a class now. Okay, Murli, no issue. So this is equals to A transpose A whole inverse A transpose into B. So that x cap, which is the approximate value, okay, I hope this is clear. So let's go to the intuition. So in the first class, it's taught about residual. So if you don't have solution, then you have to find the residual, right? So this residual, okay. So whenever the tall matrix is there, and if we B lies in the column space of A, there exists an X, okay, such that Ax is equals to B. If columns of A are linearly independent, then X is unique. So definitely if it B lies in columns of A, then column space of A, then the column space of A should be linearly independent. Then X is unique, okay. So this is also condition. If columns of A are linearly independent, then X is unique, okay. And there exists a solution. So in that case, you have to find that left inverse, okay. And you can directly use this X is equals to A inverse left into B. This is very, so far so good, and that is very straightforward. Now, what if B doesn't lie to the column space of A? This is the problem for these squares. So there does not exist any x belongs to our power n such that Ax is equals to B. Okay, so in that case, we will find this residual. Okay, so residual will be what? Suppose you are finding any problem, x is equals to Ax is equals to B, then residual will be, okay, let's see this like this. Suppose Ax is equals to B, you are trying to find x is equals to what? Okay, now let's say x cap is approximate value. Okay, so x cap is equals to B, not as possible. Okay, so in that case, you find residual as Ax minus B. So this is the error, okay, that will happen. So this mod of 2 is equals to this particular thing. Then you have to minimize it such that you can find x. Okay, so you're trying to minimize it. So this minimizing is r1 square plus r2 square, so on and so forth to r1 rm squares. Okay, so if you minimize it, then this is the problem for least squares. So for example, let's say x cap belongs to R power n, which it minimizes this thing is called the least square solution to x plus b, where this this ax bar plus b is not there. You remember, there can be, sometimes it can be, but most of the time it will not be, because that's why there is no solution existing. Okay. Now, this x cap is a least square solution. What you have to make sure? You have to make sure that this particular norm is less than the actual norm. Okay, if you do the column interpretation. So what does this mean? If you write A as a column, that is A1, A2 to AN, and you are doing this AX minus B. So what does this mean? This means this is actually the linear combination. So A1X. So sorry, I'll write like this. AX minus B is equals to, you can write A1, A2, ANX minus B. So it can write X1. This is also vector, right? X1, A1 plus X2, A2, so on, X and AN minus B. Okay, but if you try to do the norm, so what it will be? Norm will be simply x1 a1 square plus x2 a2 square, so on, b square. Because this is actually a vector. Okay, so this is the row interpretation. And if you do the column interpretation, okay, so column interpretation is if you write like this, so it will basically coming like this. Okay, so let's say some examples. I hope this is clear. Uh, if it is not clear, just let me know. Only one student is there, but I also don't have any motivation. But if A is equals to 2 minus 1, 0, so in that case, this equation is not satisfied. Means if you have two equations, some two equations are there, and that is not intersecting anywhere. Okay, solution means it should intersect some point. Okay, if it is not intersecting anywhere, then there is no solution. But in that case also you try to minimize this gap. Okay. And then try to find the approximate solution, that is what the least square is. Okay. So
Ma'am, actually residual is the error value. Mean difference between actual value.
yes. Residual is the error.
Okay. Okay, and can you suggest me any books or any YouTube
Yeah.
videos related
Yes.
solving this problem? Because last assignment I got a lot of mistakes in fifth
Okay.
one. Mm,
So
mm,
actually Gilbert Strang is a MIT professor. MIT, if you know, so MIT is the
mm.
world best university. Okay. From his lectures only
Okay,
I had I got interest in linear algebra. So this professor
okay.
like video lectures are there in the YouTube. You just try to go through that, and also this book is also there. Gilbert Strang. You just type in the uh, ha
Gilbert Strang. Okay, ma'am.
ha.
Thank you. Actually, I'm interested in maths, but actually the last session in fifth one, I got a lot of mistakes. Why I don't know.
Okay.
Actually,
Mistakes, okay. Like, can
mm.
you tell me, can you give me some survey, like, whatever I'm teaching in the, just keep this today's lecture apart, because those students have joined, so
Mm,
I also didn't have any motivation.
mm,
But in previous lectures,
mm,
like,
mm.
we solved, we first went through some concepts, then we solved some problems. Is it helpful for solving the NPTEL assignments?
Yes, ma'am. Yes, ma'am. Actually, it is actually the right way for doing that. First, we have to analyze the what are the concept, and then we are doing the problems.
Yeah,
Actually, it is the right way. But
yeah.
I don't know what happened. How? What is the reason I can't solve
Acha, what are the
those
questions? What
problems?
were the questions in week 5? Like that you did mistake there.
Um, I think that gram grams
Acha, that
that
QR decomposition, right?
you are decomposing. Actually, I got error in that area, a lot of error.
Okay, okay.
Mm, mm, mm.
That's fine.
I think, can you suggest me
Yeah.
any
Please,
way to
please go through this
improve?
Ilbert Strand book is also there in internet. You go through that. That's very good.
Okay.
Uh, yeah,
Oh,
and
oh,
this QR
mm,
decomposition will be very will become easy if you do through this what is that gram space criteria that
um,
V1 vector. You are trying to make all the vectors as orthogonal, so try to do using that. If
mm,
though you will not get any error in that. Okay.
mm.
Yeah,
Okay.
yeah.
Okay, ma'am.
I don't know. So, you didn't got any notification that my class got preponed from 6 to 8 to
Mm,
2 to 4.
yesterday, ma'am, but actually I forgot the time. So I joined late. I think others, well, the time will be the problem. That is why others are
Yeah,
not
that's why.
joining.
Otherwise, in my class, at least 13
Mm,
students were there. In
mm,
that
mm,
through interaction, I could solve it. It is a very
mm,
good thing. And now
mm,
motivation is not there to go.
mm. Yes, ma'am.
Monica, you are also joining now.
Mm.
Like, what is a like you got a notification now or what? Uh, Monica is actually new to my class. I don't know. Okay, Apili, that's fine. So in today's class, that's the only thing that
Mm.
we did. Least square. Least square is very easy and good to go. Like you can definitely got like score well. But yeah, you can skip some LU and that QR thing. Like that was very some proofs were there. Similarly, this condition number, you can directly go to the proof and try to learn and attempt the exam. Uh, yeah, can you tell me
Okay,
this
ma'am.
this
Okay.
subject is compulsory for you?
Uh, yes, ma'am, because it is for my PhD work. It is a coursework, assigned coursework, linear algebra and data
Okay,
analytic
that
with
too
Python.
applied
These
linear
two
algebra.
courses are from NPTEL.
So where are you
Applied
doing
linear
PhD?
algebra. And I have joined in Amrita Vishwavidyapeetham,
Oh,
Coimbatore.
okay.
Mm.
Okay, okay.
Mhm. That I think these assignments are enough for our exam. That is solving assignments and submitting it in on time.
Yeah. Assignments should be submitted on time. Like what you are asking, can you repeat?
Yeah. I think I got less mark in last assignment. Whether
No,
it will affect our
no issue.
final
Out
score.
of 12 assignments,
Mm,
your only
Okay.
8 assignments will be counted.
Okay, ma'am. Okay, okay. That's my actually my I got confused.
That's
Hmm.
no
Hmm.
problem at all. Only
Okay.
eight assignments will be calculated.
Okay. Okay, ma'am. Okay, ma'am. Thank you.
So okay, I'll record some session and then upload it there because anyway I have to do again because this recording it was not done in the initial class. So it's fine. Let's break let's finish this class here only. If you have any doubt, you just let me know. Yeah.
Okay,
And
ma'am. Okay. I will go through the videos again, and if I stuck anywhere in the problems,
yeah.
I will let you
Problems are
know.
very
Hmm.
important to do. Anyway, the sixth week lecture was based on
Oh,
the this thing only, linear algebra. Sorry, least squares.
mm,
So I saw all the problems. It's very easy. Anyway,
mm.
in the next class, or I think the recording that I'll upload. In that I will teach. Okay. Okay.
Okay. In that you will upload the
Yeah. That
solutions also
yeah.
for the
I'll upload
problems.
because anyway that we have to do.
Okay.
Otherwise, this recording is not proper, and as a compulsion, I have to do again. So that's the problem. Okay, I'm really fine.
Okay.
Yeah.
Okay,
Yeah.
ma'am. Oh, thank you, ma'am. Thank you.
हाँ भैया, ठीक है भैया, आके मैं लेकर आपको पैसे दे दूंगी। हाँ ठीक है। हाँ हाँ हाँ, मैं आज रात रात में ले लूंगी।